Let's solve problems that is related to the relative motion in 1D and 2D motions from chapter 4.5. Here, I would like to solve problem number 77. So, a cyclist traveling southeast along a road at 15 km per hour feels a wind blowing from the southwest at 25 km per hour. To a stationary observer, what are the speed and direction of the wind? Okay, now let's draw our coordinate system. This is our north, east, west, and south. Okay, so basically, cyclist is cycling to the southeast along the road at 15 km per hour. It's exactly 45. It's moving in this way. Okay, so this is the speed of the cyclist relative to the earth, okay, which is equal to 15 km per hour. Now, then there is a wind blowing from southwest at 25 km per hour, which means it's blowing in this direction, which is velocity of the wind relative to the earth is equal to 25 km per hour. Now we have to find that to a stationary observer, what are the speed and direction of the wind. So that means if his stationary is here, then what will be the speed of the wind relative to the observer? Okay, so that means we can just use the Pythagorean theorem to find what is the wind, speed of the wind relative to the earth. Wind relative to the earth, which is equal to velocity of the cyclist relative to the earth squared plus velocity of the wind relative to the earth squared. Okay, so that means velocity of the wind relative to the earth will be equal to 15 squared plus 25 squared. So you should get that it should be equal to 29 km per hour. Okay, now then you have to find the direction of the wind. So direction of the wind relative to the earth will be that theta angle, right? So that means theta will be equal inverse tangent velocity of the cyclist relative to the earth divided velocity of the wind relative to the earth. So that means if you plug the numbers, you should get that your theta is equal to 31 degrees. Okay.